Newton's first law of motion is any object that is moving will keep moving at the same speed until it is acted upon by a net force. Any object that is not moving will keep not moving unless it is acted upon by an equal force. For this example, a ground ball will be rolling and another stick will be stopping it. For the ball to travel in a curved line, a force needs to be acting towards the center. The ball will not fall out of the stick because of cradling. The lacrosse stick is the force that keeps the ball from falling out. The smaller the radius, the larger the force needed. The faster you go, the larger the force that is needed. Speed is the rate that an object travels a distance at. An example of speed is to see how long it takes a thrown ball to reach someone 10 feet away. In this example, it takes 2 seconds for the ball to reach Erin. Acceleration is the rate that an object changes its speed and direction at. To calculate acceleration, you do the later velocity minus the earlier velocity over the later time minus the earlier time. Erin will roll the ball up the driveway with her hand, and it will show how the ball will speed up. When the ball nears the end of the driveway, it will slow down. Velocity gives the speed and the direction that an object is traveling at. For this example, we will see how long it takes the ball to go into the left corner of the goal after Erin shoots it. The ball takes 2 seconds to go into the left corner of the goal, which is marked by a yellow cone. Mass is the measure of an object's resistance to acceleration when a force is applied. It is a response to a force. Weight is the force that Earth exerts on an object. Weight changes on the moon because weight is the measure of Earth's gravitational pull on an object, not the moon's. Mass, however, would not change on the moon. Newton's second law of motion is if a net force acts on an object, the object will accelerate in the direction of the net force. The acceleration depends on the mass and the force. The lacrosse stick is acting on the ball to shoot it. The stick is acting in the direction the ball will go. Now Erin is throwing the entire stick. The stick has more mass than just the ball. More force is needed to throw it. Newton's third law of motion is commonly known as every action has a reaction. When an object A exerts a force on another object B, B exerts an equal force on A, but it will be in the opposite direction. While the people are throwing the ball against the pitchback, the ball is exerting a force on the pitchback, while the pitchback is exerting an equal force on the ball in the opposite direction.